Something really useful about power series is we can use them to represent rational functions. This is going to be super helpful once you get farther in calculus, because it is much easier to find the integral of a power series than it is to find the integral of a rational function. So let's figure out how we can take this h of x function and turn it into something that looks like this, where we have a series that has x to an n. Something that's really important to know is that this is something we know is true. So we got 1 over 1 minus x equals the sum from n equals 0 to infinity of x to the n. And the interval of convergence of this is really important. We have to look at only when x is in between, x is less than 1, right? Because if x was bigger than 1, then this sequence, it wouldn't converge, right? It wouldn't approach a single value because x would keep getting bigger. If x was big and then n got huge, well, that wouldn't converge, it would just shoot off to infinity. So the only place where this power series would converge is if we had a decimal plugged in for x, right? So if there's a decimal plugged in for x, then this is going to get smaller and smaller and smaller and smaller and approach 0. So we need it to converge. So make sure you always have this interval written when you do that conversion, I guess. So let's take a look at this h of x. We need to get it to look like 1 over 1 minus x. So the first thing that we notice we can do is we've got a greatest common factor here in the denominator, so we can take out a 2. 2, 1 plus x. Okay, getting closer. That's like the same thing as saying 1/2 times 1 over 1 plus x. And that's almost right, but we've got a addition symbol there where this is subtraction. So the only way to get around that is to kind of do some rewriting. I'm not going to change anything. I'm just going to rewrite it. So 1/2 times 1 over 1 plus x is the same thing as 1/2 times 1 over 1 minus negative x. And we can put parentheses around this to kind of block it off, just to say, hey, you know what? My x in that formula, that's going to be what this is now. So instead of having a positive x, I'm going to plug in negative x instead. So now I've got a 1 over 1 minus our variable, and we can use that when representing as a power series. So going and plugging this into our power series, we got the sum from n equals 0 to infinity, and we have to include our 1/2. And instead of x, we're going to put the opposite of x to the nth power. Another way that we can write this is if you wanted to take that negative out and make this like n equals 0, negative 1/2, that still has to be to the n power, times x to the n. That's another way that you can write that. Either way. But we do have to make sure we include the interval of convergence. So this one's only going to converge when the absolute value of negative x is less than 1. Now, the absolute value of negative x is the same exact thing as the absolute value of x. So we can simplify this and write it like so. All right. Check out the next video where I do one that's a little bit trickier.